Okay, so we started 2.5 yesterday. This is exponential function, context, data, and modeling. So it's a lot of what am I going to do with these exponential functions? And then there's a lot of calculator work in these. So we worked through example 1 yesterday, but we're going to pick up on example 2. It says the table gives the population of a city in millions for selected years, where t equals 2 represents 2012. And why is it important that it establishes that? Good. So it's years since 2010, and 2012 is not my 0. It's not my 1. It has to be my 2. So if 2012, this would be x equals 2, okay, or t equals 2. But when I type it in the calculator, it's going to be x, which means 3 years later, in 2015, this x would be 5. And then 2018, that x would be 8. And then 2021, that x would be 11. Obviously, that's important because that's what we're going to put in our x values. So then when I go to my stat plot, I go to edit, I make my x values 2, 5, 8, and 11. And then I'm going to go to my y values, 0.801, 0.933, 1.36, 1.85. And then we know this to be exponential because it tells you to use your calculator to run the exponential expression. If we didn't know, if it said to first determine which regression is the best, then obviously we would have to use that to figure it out. But this time it tells you exponential. So then I'm going to go to my stat, I'm going to go to my calc, and I'm going to go down to where it says exponential regression. We're going to answer questions on it, so I'm going to make sure I store it in my Y1, and I get my model, which would be y equals the a is 0.626 times the b 1.101 raised to the x. Everybody got to there? Yes? Questions if you did not? Okay, this could also be written as f of x, obviously, because this is a function. But because it gave the y here, the y would have been fine to keep it there. Now, B says use the model to predict the population of the city in 2023. So if it's 2023, what's your x value? 13. So you have two options, right? We can either graph it, we could go to second calc and go to the value, or we can go to our main screen and we can type in the Y1 and do 13. What do you get when you do that? 2.189, that's a terrible color, 2.189 millions. Okay. Obviously, this is people, right? Because it said people, population of a city. Okay. And then C says, during what year did the population reach 1.5 million? So yesterday we talked about it quickly, but we said there's two ways to do this. God bless you. There's two ways to do this. One is do 1.5 equals 0.626 times 1.101 to the x. So without using my graphing utility for the graphing component, God bless you, I can take this equation and solve it for x. You're going to have to learn how to do this, so let's refresh it. If I'm trying to get to that x, I have to isolate the exponential part, so I'm going to divide both sides by 0.626. And I get 1.101 to the x equals, and I'm going to keep this as this because eventually I'm going to type it in the calculator. But for now, I'm going to keep it. And then how do I get to that exponent? You can ln. You can log of any base, both sides, right? But we can ln both sides. I'm going to ln here. I'm going to ln here. And then the exponent bumps to the front. So this becomes x ln 1.101 equals the ln of 1.5 over 0.626. And then to isolate that x at the end, I'm going to divide by the ln of 1.101. And I'm going to let my calculator do all that work for me. So I'm going to ln, you can do it however you want, but I'm going to ln just the numerator, 1.5 divided by 0.626. I hit enter. And then I'm going to divide that by the ln of 1.101. And x equals 9.082. ln is under the log next to the 4. Okay, that is one way to do it. And again, we will revisit logs a little bit later, but that is definitely one way to do it if you remember how to manipulate your logs. The other way is what? What's the other way I can find that spot? Use my graph, right? What do I put in? So I'm going to put 1.5 in my y2, and then I'm going to graph it. All right, so I put 1.5 into the y2, and then I graphed my function. My window is my standard negative 10 to 10, okay? But on here, if I want to see where they intersect, I'm going to go second, trace, and I go to intersect. And remember, it asks you, what are you on the first curve? Mine's blue. That's the blue curve, so enter. Are you on the second curve? Yes, that's the red, enter. And guess, I hit enter for the third time, and it's going to bring me to that intersection.
Can you do that again?
Yep. So I entered in my y, right? My y1 I have from my regression from when I ran it. I saved it. And then my y2, I want to make 1.5. And then I hit graph. And this time it's already in the window. But if it wasn't in the window, you can zoom out or adjust your window. And then I go second, trace, and I get to the calc menu. And number 5 is intersect. So if I go down or if I hit 5, I hit intersect. And then it doesn't matter which one it's on, first or second, as long as it eventually highlights both of them. So I'm on my first curve, I'm on the second curve, and then I hit enter again to guess. And it will put you at the intersection, which is exactly what we got. Well, no, it's not exactly what we got. It's a rounded. On this side, okay, it's more rounded. On the right side, 9.072 would be more accurate. So much. What is it asking? What year did it reach 1.5 million, right? 9 is not the year. 9 is the years, the number of years after 2012. So what would be 9? No, sorry, after 2010. So what would be 9 years after 2010? 2019. That's the year, okay? I don't need the decimal because it's asking for a year. So in both of those cases, my answer would have been 9 years later. Okay, thank you. Be really careful what it says. So speaking of the E. Oh, sorry, Allison, thank you.
Would you, because it's saying what year would be.
All right, now let's get into E. So E is called Euler's number. It is also the natural base. And it is sort of like we use pi. So pi is this as a symbol for a number, right? Pi is like estimated as 3.14. E is estimated as 2.78. No, 2.718, sorry, or 2.72. And it is used to show, it's called the growth constant. It's used to show continuous growth, okay? So it is part of our continuous exponential functions. If you remember PERT, right, something that grows continuously, it uses E as its base. So it's used for compounding continuously. It will also be part of ln. ln is log base E. Okay, those are the same thing. So these are some of the formulas you have to know when we get into exponential functions. Okay, the first is if something has an increase. So if something has growth, exponential growth, then we use the y equals, just like we did before with our exponential functions, the y equals a times, and we build our base. If it is an increase of a certain percentage, then we take that percent, we convert it to decimal, and we add it to 1. So if something had a 25% increase, then inside this parentheses is going to be, I move my decimal back twice to get the decimal form of that percent, and I add it to 1. So inside would be 1.25. If there is and then it's raised to the x power, just like all of our exponential functions. If there is a decrease, so we're talking about exponential decay or money depreciating, something like that, then we subtract it. So if it had a 25% decrease, then I would do 1 minus 0.25, and I get 0.75. So if my base is under 1, it represents decay. If my base is bigger than 1, it represents growth. And we did that with our functions, right? We did that with our exponential functions, but now you're going to have to understand it in words and real-world scenarios. Half-life and double life are how we use a function when it doesn't give you the percent. It says the substance reaches half the amount of the original after a blank amount of time, okay? So if it says I have, and this is a lot of like bacteria and stuff like that. If I have this and it reaches its half-life after 2 years, then I take my A, which is my initial value. My base is 1/2, and my exponent becomes T over H, where H is the number of, or the time it takes to reach half its population. So if it said after 10 years, the whatever it is, bacteria, blah, 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 whatever that is, has this exponential decay, reaches half its population, then my exponent, whatever my A is going to be 1/2, and then T over, I said 10 years, so the 10 goes in the bottom. If it's double life, it's the same concept, except instead of being 1/2, it's going to be 2. So if something doubles every 5 years, then whatever my initial value is going to be my A. The 2 is the base. And what did I just say? 5 years? So it would be T over 5. Yep.
Is that a negative or a 1?
No, it's the A. Sorry. That's where the A goes. And then the last thing, and hopefully this is something we remember from Algebra 2, and that is continuous growth, okay? Continuous growth, we call it PERT, just because those are the letters that it's used. But P0 is your initial value, E is your natural base, and then RT is the exponent on that natural base, the R being the rate of growth in decimal form, and the T being the time it's in that, whatever it is. Was that your question? Yeah, T is time. So all of these, if we're keeping track of a reference sheet, all of these go on our reference sheet. Increase, decrease, half-life, double life, and continuous. Okay. All right, so they'll look something like this. I'm getting attacked by a teeny tiny gnat. Won't go away. I think I got him. Yeah. Sorry, bud. All right, so it says create the model. A says, I just recorded me. All right, A says the value of a car C is 68,000 and it increases by 1.75% every year. So we're not actually figuring anything out other than just the model here, okay? First of all, is this increase or decrease? It's increase, which means I'm going to take my percent, convert it to decimal, and add it to 1, and that becomes my base. So 1.75 goes to 0.0175, good. And then I get my initial value, which is 68,000, times 1 plus 0.175 raised to the T. Did I give you a variable? Yeah, T. And this, it said cost is C. So I write this in function notation. This would be C of T, like that. Now, sometimes it literally will leave it like that. You'll see on your multiple choice on your AP Classroom, sometimes it will actually leave it like that. And then sometimes you will rewrite it as 68,000, this is a 0, 0.175 T. That should be a 0. Yep.
Will we have to memorize these equations for the test?
You have to know the increase, decrease, the last slide. Yes.
And all of those equations.
Yeah. All right, B says there are 250 grams of bacteria in a dish. The bacteria doubles every 8 years. So if it doubles, what formula are we using? The double life one. So we start with our initial, then our base is 2, and our exponent is T over H, H being the number of years it takes to double. So it'd be T over 8. And this time it didn't give me, so I'm going to rewrite this as function of time. It doesn't matter, like I could use f of, I could use whatever. Just make sure the variable in here matches the variable you use for your exponent. I could have done f of x equals 250 times 2 to the x over 8. It doesn't matter what those variables are, as long as the input is the input and the output is the output. Yeah.
Will there be versions of these equations on our test where it gives us the time and then we have to?
Yep. That's such a good segue. Go to example 4. A says Jake lends $20,000 to his friend at an annual interest rate of 5.7% compounded annually. Use the exponential growth formula to find the amount owed by his friend after 6 years. Now there's words in here that are so important, and the first is compounded annually. That is not the same as compounded continuously. Continuously, if you look on B, it says continuously. Continuously is PERT. Annually is your regular standard percent increase. So I have my initial value, 1 plus the rate raised to the t. So he starts with how much? 20,000. Not equals, sorry. Times 1. He's earning interest, so this is an increase, right? Plus 5.7% would be what in decimal form? 0.057 raised to the t. That's my function. And it wants to know how much he owes after 6 years, so it'd be 20,000. And you can actually type it in your calculator as 1 plus 0.057, or you can make it 1.057 raised to the power of 6. If you type it in your calculator, you got to make sure you put in parentheses, but it will know to raise just the 1.057 to the 6th power. What you cannot do is do 20,000 times without parentheses 1.057 and then raise that to the 6th. That is the wrong answer. But if you just type it in, your calculator will follow order of operations, 20,000, open the parentheses, 1.057, close the parentheses, use your caret, and raise it to the 6th power. $27,892 and 016, which becomes $02. Okay, it's dollars. You have to know it's dollars, so we round it.
What's the answer again?
$27,892.02. Rolina.
My calculator keeps saying 49.
Let's talk about it because we're going there, right? So B says Elsa invests $200 compounded continuously. Continuously means it's happening so fast that our normal functioning brain can't figure it out. So annually means he starts at $20,000 and at the end of the year he owes $20,000 times 5.7. And then at the end of year 2, whatever that balance was, he owes that plus 5.7%, right? Continuously happens so fast. It's like you have money on that card, it's compounding, it's compounding, it's compounding, it's compounding.
How fast is it?
More than every minute. It's so fast that's what that natural base is.
So how do you have an equation if it's like not a certain
Because
amount?
E represents that natural base. Eventually, after so long, it will level off. Yeah. But it's so fast we can't say. So you can say it compounds monthly. You can say it compounds, and there's an equation for that. But when you say continuously, that's why we use PERT. So our base is E, which is the natural base, which is what happens if we continue to raise something to a higher and higher and higher and higher power. It eventually levels off. So because it's continuously means we use PERT, P times E to the RT. So our principal amount was $200. Our base is E, and it's raised to the R in decimal form. So if it's 6.5%, it becomes what?
0.06.
Good. That's 0.065. And how many years? It says accumulated after 8 years. So in your calculator, you're going to do 200. The E is above the ln, so second ln, 0.065 times 8. And I get $336.41. Like 200, second ln brings in your E. And then in the exponent, 0.065 times 8. So continuously would be the most amount of earned. If I had done A with continuously, it would surpass my annually amount.
That's my thing.
Continuously is how credit cards get you. Yeah. Good so far. That's also a small amount to start with and 8 years, right? Yeah.
It's nothing.
Yeah. Right. The table gives values for the amount of a certain substance in grams on certain days. The data is modeled by an exponential function f given by f of t equals 3 times e to the rt, where t is the number of days since day 0. The constant r is defined as the continuous growth rate of this model based on the table. What's the value of r? First of all, if we look here, okay, this is technically just PERT, right? Our initial value was 3. The base is E, and the exponent is RT. So they just set up PERT for you, compounded continuously. If that wasn't given to you, if it said that this was represented by an exponential model, then I would plug record. Okay, so what I was saying, I think, was that if it didn't give you the model and it said you have to build an exponential function, now we would use the exponential regression on this kind of information. There are times on your AP exam in which you are going to get given a model like this, and there are times in which you have to build it and then answer it. So make sure you read carefully, because if it already gives you the model, don't waste the time creating the model. Okay, so now it says, first of all, based on the table, what is the value of R? In this table, I have 2 sets of input-output, right? Those are basically 2 coordinate points. One is 0, 3, and one is 6, 7.425. Now, let's say I grab the first point, right? If I grab that first point, my input, which is t, this is going to be my t, okay, is 0. My output, which would be the f of t, is 3. Plug it in. See what happens. 3 equals 3e to the r times t is 0. So we plugged it in. You with me so far? What happens to my exponent? What is 0 times r?
0.
To the 0. I just got rid of my r. I can no longer solve this. So if you are looking for part of your equation and one of your data pieces has your t as 0, you obviously can't use it. I can't use this one. I have to use the other one. There might be 2 choices on the other one, and it wouldn't matter which one you pick, because if this is the model that works for it, that's how it got the data. But in this case, I only have that one. So 7.425 gets set equal to 3 times e to the r, which is my unknown, times t, which is 6. You with me so far? Remember the logs. Here they come. So if I want to get to that exponent, I have to break apart the right-hand side and eventually get to the exponent. So the first thing I'm going to do is divide both sides by 3. And I get 7.425. I'm going to leave it over 3, so this is kept exact. Equals e to the 6r. Now, if I have an exponential expression and I cannot change the base to be the same, which we cannot, then we ln both sides of the equation. You can log or ln, but the benefit of lnning when there is an e is that ln of e cancels out and gives you the exponent. So now I have ln of 7.425 over 3 equals, ln and e are gone, 6r. And then I divide both sides by 6. And then in the calculator, I do that whole thing. ln of 7.425 divided by 3. Hit enter or close your parentheses, and then divide that by 6. I don't know, what's my job, I guess.
Oh, yeah.
Yeah.
You kind of said it.
So this is what? What does R represent? The rate. What do you normally see rate in? Percent. So it might be, like if it doesn't say in percent, then actually this answer would work if it was open-ended. You could give 0.151. But if it was multiple choice and you saw your answers in percent, you would have to move this guy back, which means you have to add on 0.4. And it would be 15.104%. Did I do that right? Yeah. Yeah. So again, if it's open-ended, both answers work. If it is multiple choice and you see percents, then you have to know to move it. Questions?
No.
Okay, if you have a graphing utility, you could also have taken this side of the equation and put it in as your y1. r being x. And you could have taken this side of the equation and put it in as y2 and then saw where they crossed. Yes, that is an option. So do it. Y1, type it in. 3e to the rt, which would be x times 6. And the other one, 7.425. And then graph it. I put, here, let me go to my y equals so you can see it. So I put the f of x, which was 3 times e to the rt. Our r is x, right? Oh.
Wait, 3 times.
I don't know what FRQ I'm giving you yet, so I don't know if that answer is yes, but probably. All right, so the first one is your 3e to the 6r, right, which would be 6 times x. And the second one was 7.425. And then if I hit graph, and I go to second trace, and I go to intersect, first curve, second curve, third curve, I get my x and my y. My y is the 7.425. And my x is 0.15104. This type of question, you would always have a calculator for because you can't do the ln without it. So you could do either of those processes. Does that make sense? There's going to be times in which you have to log, so it's good to keep reviewing that. But in this situation, you would always have it. Okay, example 6. And this is like AP. Now that last one would have been an AP style question too. You'll see it on AP Classroom. But this one too. The zebra mussels are an invasive fingernail-sized mollusk that are infesting some of the freshwater lakes in North America. Their population increases on average at a rate of 5% per day. Let 700 be the amount of zebra mussels in a certain lake at time D equals 0 days. Which of the following function G models the amount of zebra mussels after T weeks? So fast forward to May 13th. And maybe this is a question in which you're like, holy crap, that's a lot of words. I'm going to skip it and come back to it at the end. Feel free to do that. Do the easy ones first, okay? But eventually you're going to come back to this and you have to understand what it's asking. First of all, it says, we don't even care what the subject is. Zebra mussels. I didn't even know they existed. Okay. What is important is that there is a percent increase, right, at a rate of 5%. And it says 700 is the amount at the certain lake where D equals 0. So 700 is my initial amount. If I look at all the answer choices there, they all say 700, but that is something I could look for. They also all have a percent increase because it would be 5% would be 0.05 and it's increased, so it's 1.05. That is also something I would look for. If one of these had a 0.95, that would be a percent decrease. I would know to cancel out immediately. But those two things are the same for all of them. So what's changing is the exponent, right? In the actual wording, it says that it changes per what? Per day. So the initial exponent would be per day, and it says after T weeks. So if I did 700 times 1.05 to the T, that would be per day. You with me so far? Then what is it asking for? Weeks. So if it's weeks and I have day, do I raise it to that power or do I divide it by that power? We're going to raise it because if it's 1 day and I want to see how much it would be per week, it's going to be 7 of the initial values. Does that make sense? So this would then be raised to the 7 and that exponent becomes 7t. If it was reversed, we would divide. If it had said this is what it is per week, what would it be by day? Now I have to take that initial value and break it down smaller, and that's where the division would happen. Does that make sense? Questions? Like I said, I'm literally just going to start this because there's a lot of overlap in this section, okay? So 2.6 is competing function model, that should say completing, function model validation, okay? And this we've done a lot of. This basically is giving you the different types of data, and it's going to ask you to now classify this as linear, exponential, quadratic, cubic, whatever it is. So it's adding exponential in as one of your options. So now we've got 1, either 3 points or more, 2, a chart. So you will get given those 2 types of data. And then it will ask you to classify as linear, exponential, or quadratic. So if it's linear, the rate of change is constant. This is my first difference, right? First difference. We would subtract. Quadratic would be the second difference. So I would find the change, and then I'd have to find the change again. If that's the same, it's quadratic. And now we add in proportional, which we've done before, but this is now in the modeling section, okay? It meaning if I took y2 over y1 and y3 over y2 and y4 over y3, does it simplify to be the same thing? So this is nothing new. It's just in the mod, like now they put it in with real world models and data collection. Okay, so look at example 1. It literally says what type of model is represented by the data. So the first thing we have to look at are my x values increasing or decreasing by the same rate? From 0 to 2 and 2 to 4 and 4 to 6, are they increasing by the same rate? Yes. Now I want to look at my y values, okay? If I wanted to find the rate of change, I actually have to do y2 minus y1 over 2 over 0, okay? So if I'm actually looking for the rate of change, it's going to be 2.75 minus a negative 0.75 over 2. And then it would be 6.25 minus 2.75 over 2. And then it would be 9.75 minus 6.25 over 2. So that would be if I wanted to find the rate of change. If I'm finding the difference, first difference, second difference, whatever it is, I just have to do the initial part. 2.75 minus a negative 0.75 becomes plus 0.75. And this difference is 3.5. The rate of change would be over 2, but the difference is 3.5. Then 6.25 minus 2.75 is also 3.5. Again, rate of change would be over 2, but first difference is just the numerator. 9.75 minus 2.75 is also 3.5. So if the first difference is constant, what kind of model is this? Linear. Then I go to B, and I'm going from 2, 3, 4, 5, so my x's are increasing at the same rate. I look at my y's. The first difference would be 4 minus 1, which is 3, 9 minus 4, which is 5, 16 minus 9, which is 7. Those are obviously not the same. So then I go to second difference. 5 minus 3 is 2. 7 minus 5 is also 2. So what's the best model here? Quadratic. Second difference. Yep. When Nati comes back. Questions on those? If it's not first difference, I then go to second difference. If it's not second difference, and then I see if I could divide it. So 4 over 1, 9 over 4, 16 over 9. If those are the same, then it's exponential. So those are your 3 tests right now. First difference, second difference, exponential. All right, C. My x values are increasing by the same amount. I can do 3 minus 0.75, 12 minus 3, 48 minus 12. They're obviously not going to be the same. This is 1.25. This is 9. This is 36. Second difference would also not be the same. This would be what? 7.75, 27. So then I try exponential. 3 over 0.75. I want it to see if it equals 12 over 3. I want to see if it equals 48 over 12.
Oh, so we're just testing every single.
Correct. Yep. This is 4 and this is 4. So as long as 3 divided by 0.75 is 4, and it is, now I know this is exponential. Now if it asks you to explain why, because a lot of times it will, you can say as your input values increase at a constant rate, your output values do blank. So if it's linear, your output values have increased by a constant value. The second difference of the output values increases at a constant rate, or the output values are proportional is what we would say for exponential. So what are we in 2.6? We bring in what is called a residual plot. A residual is the distance from the actual point to the point on the regression model. So a residual plot is used to compare our predicted model with our actual data. If the residual plot has a pattern, then the model is not appropriate. And if it does not have a pattern, then the model is appropriate. So this would be like a multiple choice question. You would get a series of graphs and it would say which of the following is appropriate or which of the following is not appropriate. And then it will give you a graph that looks something similar to what you're seeing on the bottom. On the left-hand side, and it may not have the line. Sometimes it has a line, sometimes it doesn't. On the left-hand side, this is my initial value, okay? This is not a residual plot. This is my actual data. And we use the stat plot, and that's what all these dots are, right? The stat plot plotted all those things. And then it ran a linear regression. And then it put it into the Y1, and then it plotted it. And this is what it looks like. So the green line is my residual model. This is what we think will predict what happens in the future, okay? And then all the dots are the actuals. So dot, actual, okay? Now, every time the dot is above the line means that the model under-predicted what was supposed to happen. The line represents the model. So if the line is under the dot, it's an under-prediction. If the line is above the dot, it's an over-prediction or an overestimate. A lot of times it's going to ask you, here's my graph. The first thing it's going to ask you, is it appropriate or not? The second thing it will ask you is, at year 4, describe the actual to the model. And if I went to year 4 here, this is year 4, right? That dot is above the line. So we would say that the model underestimated what it was supposed to be. So wherever the line is what we're describing. If the line is under it, it's an underestimate. If the line is above it, it's an overestimate, okay? And then this is a residual plot. This is if you're looking to see if there's a pattern. So if it gives you residual plots and there's a pattern, it makes a U, it makes a line. Some go up, some go down, but they go in a pattern. It's not an appropriate model. If it is scattered like that, then it is an appropriate model. And in this case, your x-axis is your regression. This is your regression line. So now the x-axis is my regression. Every dot above it would be over the line. Every dot below it would be under the line. It will also ask you to get R, and this is not on your slide, so make sure you add it in. R is the value of the actual data minus the predicted. So if R is positive, then the model underestimated. If the R is negative, then the model overestimated. And think about again why. If it's positive, then the actual was above the line. So the line was an underestimate. If it's negative, it would mean that the actual was under the line. So the model overestimated it. We are going to revisit all of this tomorrow, but I want you to at least have a little bit of a foundation so before we freak out, okay, and shove it all in, we understand it. So remember, you're looking for a pattern or not. So these are now residuals. It says these are residuals. These are not your initial value. So if the residual has a pattern, like the right-hand side, you see this goes like this, that's a pattern, right? This is not appropriate. If it's scattered, some above, some below, and not in any pattern, then it is appropriate. For what? For the pattern or for the appropriate, non-appropriate? It will simply ask, is this an appropriate model? Meaning, was that a good regression? If it is a good regression, there will be no pattern to the dots. If it's a bad regression, there will be a pattern to the dots. Because it should have been something different. Right? Like there is clearly something wrong with this data because all of these were underestimates in the same way these were underestimates. So there was another model that would have suited it better. Does that make sense? Okay.